Identifying horizontal and oblique asymptotes. So in example 6, use the equation to determine whether there is a horizontal or oblique asymptote and determine the equations of these asymptotes if there are any. So we're going to use the rules on the above page. So you're going to look at the degree. You have the degree of 1 over the degree of 2. So that would mean that's the very first rule at the top of the page. The degree in the numerator is less than the degree of the denominator. So the horizontal asymptote is at y equals 0. So we'll just sort of abbreviate and say it's a horizontal asymptote, y equals 0. The fact that it says y equals 0, we know it's horizontal based on the y. Let's look at B. Here we've got degree 2 over degree 1. So this would actually be the third rule here. If the degree in the numerator is greater than the degree of the denominator, there's no horizontal asymptote. And then if we refer back to the oblique rule, the degree is 1 more in the numerator than the denominator. So this actually would have an oblique asymptote. So to find the oblique asymptote, we're going to divide. I'm going to use synthetic division. I should mention this wouldn't simplify or reduce. X minus 3 is not gonna, you're not gonna get x minus 3 if you tried to factor that. So we're going to do synthetic division. So we're gonna have 3. Remember, we need a 0 here. In fact, I can rewrite this as negative x squared plus 0x plus 4. So you can see that that is that coefficient. Negative 1, 0, and 4. Bring down the negative 1, multiply, add, multiply, add. So this would be a negative x minus a 3 minus 5 over x minus 3. So my equation would, in the correct order, I would put that fraction part first. So y equals a over x minus 3 minus x minus 3. So this would mean that I would have my oblique asymptote at y equals negative x minus 3. So again, it'll be in y equals mx plus b form when you see the tail end and write those oblique asymptotes.